Hello everyone. Today we're going to pick up where we left off and implement user input. However, before we get into it, I would like to remind you that I'm still very new to making YouTube tutorials, so if you have any feedback or suggestions, please let me know in the comments below. With that said, let's get into it. Alright, so a quick recap of where we were last time. We can hit play, and we'll see that we have all of the pieces in the right spot. However, if we try to make a move, then we just get an error. So, let's fix that. First things first, we need to define what a move is. So we're going to go over to Chess Engine. We're going to add a new class, though it's going to become a struct. This is our move. And we're going to say that this is a public struct. Get rid of this extra new line. Get rid of all of our usings except for system.threading.tasks, as we're going to have multi-threaded moves. Alright, so our move is going to contain where it began and where it ended. So we're going to go a public chess vector from 2, and then we're also going to have a constructor, public, I was about to say chess vector, public move, chess vector from chess vector 2, and then from equals from, and this 2 equals 2. Now, in the future, we would also have some more variables in here containing like flags for special moves, like was this move a promotion, was it a castle, en passant, etc. However, we're not doing that today. We're just going to get generic moves, and then in the next video we're going to get legal moves, and then maybe after that we'll get our special moves. So, for now, this is all we need. We're actually going to pop in one more thing at the top. This is going to be our public, static, read-only move. It is not an instance, however, it is just null. So, this is going to be the move that is returned if, well, the null equivalent. So, we're just going to say this is a new -1, -1, new, -1, -1. So that is by no means a valid move. So that's what we're going to use as our null move. Alright, so now that we know what a move is, we're going to want to be able to convert a string to one, as that's how we'll be receiving our user input. However, before we can work on that, we need to be able to convert a string to a chess vector, because the logic for converting a string to a move depends on it. So that's where we're going next. Alright, so heading over to chess vector, I'm going to make some room down here, and then I'm going to paste in the method, and then I'm going to be explaining it line by line. Alright, so if we look at the top, we see this method takes in strings of the following 2 formats. We have this human readable format, which is like A1 to A2, stuff like that. And then we have this not so human readable, more like a debug format, which is just the raw X and then the raw Y. So first things first, we do some pre-processing on our input. We trim all of the leading and trailing white spaces, and then we convert that to lowercase. Then we go ahead and we cache the first and the second character, as that's our X and Y. Then we check to see if it's in the first format, so is it a letter and followed by a digit? If so, we can just subtract A to convert this, our first component to an int. I don't know why I struggled to say that. And then our Y, we can just convert it from a digit character over to an int, and then we'll subtract 1 as the human readable format tends to have a 1 higher Y than we actually need. And then we go ahead and return that. Next, we check to see if it's in the second format, so is it a digit followed by a digit? If so, we do what we were doing for the Y, we just convert the 2 characters straight to ints, and we don't even subtract 1. And then we return that. If it were neither of these 2 formats, we just throw an error saying, hey, the input wasn't correct. And that's it for this parse method. We are done here. Alright, so now we're free to start parsing strings to moves, so we're going to head over to move. We're going to make a little more space down here. And then we're going to paste the method. Like I said, you can paste it as well if you head over to GitHub. Otherwise, you're going to be writing it line by line. So, like before, we can take in a human readable format and a debug format, but this method doesn't care about that because this is kind of just conveniently supported already by just the chessvector.parse. We only care about whether or not it's got an alligator in the center or not. So this is going to be how Lichess is going to be sending us inputs. But this is just how I like to put in inputs into the console. I just felt like that was more intuitive, and that's just how I told my friends how to input stuff into the console. Yes, they had to play against the chessbot in a console. That was not the best. Alright, so if we start all the way at the top of our method, we'll see it's actually a try-parse method. It returns true or false based off of whether or not it can convert the input string to a move. So let's see how that's done. Everything is done within a try statement, as I don't want any exceptions being thrown to the caller. So within this try statement, we see that first things first, we make sure our input is not null or empty. If it is null or empty, then this was a bad move. So we're going to say move equals null, and then we're going to return false. Next, we're going to remove all of the leading and trailing white spaces off of our input, and then we're going to check if the length is 4. If our length is 4, then it's in our Lichess format, so we're just going to get the first 2 characters and the last 2 characters, and then we're going to convert these to chess vectors, and then throw them into the move constructor, get a move, set, our output move equal to that, and then once we leave the ifs, we'll see that this will get returned as true, or will return true, and, we'll be happy. If the length is 5, we know it's in our alligator format. So first things first, we check to see if there is an alligator in the center of the string. If there isn't, it's a bad move, so you know the drill. Move equals null, we return false. If there was an alligator in the center, then we're going to split it. We're going to split the alligator in half. We're going to get the first half of it, which is going to be 2 characters, because, 5 minus 1 divided by 2, 2. And then we're going to parse that into a chess vector as our from, do the same for 2. That's all being done in the move constructor. We set move equal to that, and then we return true. If it weren't either of these 2 formats, then we just return bad move, which, you guessed it, move equal to null, return false. If there was an error at any point, then we'll just set, surprise, surprise, move to null, then we return false. So that's it. That is our try parse method. Alright, so now that we know what a move is, and we can convert strings to moves, the next step is to get those moves played out on the board. So this is actually really easy. Heading over to board, making some extra space, and pasting, I'm going to explain how we actually accomplish this. First things first, we cache our start and our end index of our move. Then we remember the original piece that was on the start square and the piece that was on the end square. Then we say that the end square is equal to the piece that was on the start square, and we say our start square is equal to nothing. And then we just say whoever's turn it is to move, well, it's no longer your turn, so go. And that's it. That is all the logic we need to make a move so far. However, we're going to want to be able to undo moves. To be able to undo, we need to know the sequence of moves that were made that got us to where we are now. To be able to do that, we need to write a structure that'll be able to contain the data of a previous move. So let's do that. We're going to go over and we're going to add a new class. This is going to be PastMove. This could be a public struct. No unnecessary usings. Get rid of the new line. And there we go. All right, so what defines a pass move? Well, this is actually pretty simple. All we care about is where the move took place, where it ended, and then the original data like that was housed on those squares. Alright, so what defines a pass move? Well, it's actually pretty simple. All we care about is where the move took place and where it ended, along with just the original piece data. So, public int from, and then we have our 2. So that is the from and to index of our move. And then I'm pasting this because that's really long and I didn't feel like typing it. And then we have our original piece data for our start piece and our end piece. And then we also have a constructor that Visual Studio desperately wants me to put up here, but I will not be doing that. You can do that if you want. Not like I have any authority over that, but, this is just how I want it. Alright, so now that we know what a past move is, we can actually start tracking them in our board. So if we head down here, we can create a new variable all the way at the top. This will be a new public stack of past moves. This will be past moves. And this will be equal to new. And if we come down here to our make move method, we can actually uncomment this line, which is just saying passmoves.push, so we're adding it to the top of the stack, a new pass move equal to the start and end index along with the original piece data. So that's it. Now we're remembering all of them. Next, we actually need to undo, so we're going to head down here, make some space, and then I'm going to paste 2 methods. So we don't care about this top one at the moment. We just want to know what this function's doing. So first things first, we're just checking to see if any past moves exist. If so, we're just going to get it from the stack, and then we're going to say the pieces at the start location equals the original start piece, and the piece at the end location equals the original end piece. And that's it. This method above, actually I'm going to keep that expanded. This method above just says that we can take in an amount of moves we want to undo, and we will keep undoing until we've either undone the correct amount of moves, or we have no moves to undo. And that's it. That is undoing moves. Now all we need to do is capture the user input in our program, so over here, and then we actually need to make those moves on the board. Wait a moment, I just discovered we're actually missing something in board. We need to keep track of the game state, as the next method that I'm going to have us write out is actually going to allow us to play a game between two people. So we need a new public enum game state. So our game can either be playing or white one, black one, or it was a draw. And then we actually need to keep track of that. So public game state equals playing. No, equals playing. There we go. All right. Now if we head over to program, I have a method to paste. Bam, here it is. It is our play game function. Oh boy, let's step through this. Well, it's actually nothing crazy. First things first, we just create a new board. We render it to the screen so our players know what they're dealing with. Then we go ahead and we add a spacer and say, while the game is being played out, we're going to have whoever's turn it is to go actually take their turn. Then after they've submitted their input, we're going to render the new board, and then we're going to add a spacer. If we look at the actual taking user turn function, we can see that it just states whose turn it is to move. Then we have our little label here that just defines what getting a move is. We get our user input, which we read it straight from the console, trim it, and convert it to lowercase. We see if the input was undo, then we're going to undo the past two moves. Then we're going to say, if it wasn't undo, then we're going to try to parse it to a move. If we were successful, then we're going to validate to make sure it was a legal move. Well, we're going to do that in the future. For now, we're actually just going to say it always is a legal move. And if it was a legal move, then we're gonna make it on the board. If it was not a legal move, then we're gonna complain. And if we couldn't parse it as a move, period, then we're just going to say, hey, we couldn't parse it, try again. And then we're gonna go over here and we're gonna have them try again. And that's it. We can go ahead and we can run it. Now we can see we have our board with the starting positions, and more notably, we can see it's actually saying it's our turn to move. So it's saying it's white's turn to move. I'm going to be playing white, so I'm going to go e2 to e4. And then my imaginary friend is going to be playing black, so they're going to go d7 to d5. I'm going to kill their pawn by going e4 to d5. And then they're going to be stealing my pawn with their queen. However, I don't actually like that, so I'm going to try out the undo feature. Bam, here we were before I made the decision to take. And I'm actually going to push forwards. Push forwards a lot. Oh, whoops. Yeah, so as you can see, there's an obvious issue here. It didn't promote my pawn when I made it to the end. We're going to be handling special moves after we handle legal moves, which is probably what you were thinking when I said there was something wrong. So that's what's happening next video. Legal moves, so people won't be able to pull off these shenanigans, and that's it. That is everything we need to do in this video. I hope you enjoyed. See you in the next one.